All right, I want to talk a little bit about intersecting chords and why they always form similar triangles and then what we can do with them. So first of all, if we've got two chords like this, I can make this any angle I want to. Let's just call it x. If I do that, this over here has to be an inscribed arc. So it's going to be 1/2 whatever that arc length is there. Okay? Well, this over here is also an inscribed arc. So it's also going to be 1/2 of x, whatever that number is. So if 60, 30, 100, 50, what it happens to be. So those two have to be the same. And this arc over here could be like y. So which means inscribed arc back here would be 1/2 of y. So if this was 100, this would be 50. But this one over here is also inscribed. So from here to there, it's going to be half of y. Well, I've got half of y and half of y. I got half of x, I got half of x. And these right here, these are vertical angles. So these two triangles have to be similar, which means they're the same shape, but they're obviously not the same size. Which means it sets up some interesting properties here. Now, first of all, we need to notice what the matching sides are. This side here matches up to this side here. So it's almost like a reflection, not really a reflection because they're not congruent, but the idea is there. So those two are the corresponding sides, and this side corresponds to this one, and this kind of setup is always going to be true. So it's almost like you fold these two, and you know these two you're comparing, and these two you're comparing, and then these ones on the outside you're comparing. Those are your corresponding sides. So once you figure out your scale factor, so obviously I'm getting bigger here, if I figure out what my scale factor is, I can figure out, going from here to here, what's a missing side or dividing if I'm going in the other directions. So that's the basic idea. So let's do a couple of examples. All right, so I got two intersecting chords. I can draw on two more chords to make two similar triangles. And then, so I've already got some links in here. So I've got like 2, this could be centimeters or units or whatever. This is 2, this is 4. So this should be easy enough for you to figure out. It's like, oh, I can even tell what the scale factor is there. I'm multiplying by 2. So to go to here, I would multiply by 2. Or if I didn't see the scale factor, because maybe it's not so obvious, I could say, well, 2 is to 4, comparing those two, as 3.3 is to x. And then I could cross multiply and solve. So I get 2x equals, I think that's 13.2, and then divide by 2, and x is equal to 6.6, which is what I was expecting anyway, because to me, in that one at least, the scale factor was obvious. And so once again, this is always going to be the case. Anytime I have two intersecting chords, automatically this has to be congruent to that. This has to be congruent to that because of the inscribed angle theorem. And then we've got our vertical angles here. So we know they're always going to be similar. And the only tricky part is, what matches up to what. Okay, skipped a page. All right, so I got a situation like this. And my picture's not so great. So this one's a little harder to tell what the scale factor is going from here to here. I'm getting a little bit bigger. These things almost look like the same size. So let's just set up a proportion. So I got, I could do it this way, x over 6.25, because those are two matching parts, are the same as 3 over 5. That is another way to set up the proportion. I could also do 3 over x is 5 over 6.25. But when I cross multiply, I'll get 5x, and those two multiplied together are going to be 18.75. And when I divide by 5, I'm going to get, I believe it's 3.75, which makes sense. Definitely larger, but smaller than the 6.25. And now that I'm looking at it, I can say, oh, my scale factor is, I think, 1.25 is what it is. Okay, similar situation. I'm just missing, I've got two sides. I've got to have 2 to find out I'm missing one. So once again, these two are corresponding. Those two are corresponding. I don't know anything about these two. I might be able to figure something out about those two if I knew the size of the circle and maybe some angles, but we're not going to go that far. Okay, so what matches up to what? 2.2 matches up to my x, and my 2 matches up to my 3.8. And I cross multiply and solve, and I work this out ahead of time. I think this works out to 8.36. That's in my memory, so when I divide by 2, This is about 4.4. It's not exactly 4.4, but it's about 4.4. And I think my scale factor here is about 1.9. Okay, so there's one more situation that might come up. Sometimes you might be told, like, hey, I've got this chord and it is either bisected by the radius or the diameter, or that it is at right angles to a diameter or a radius. So those things are kind of interchangeable. We know that chords that are bisected by the radii or by a diameter, kind of the same thing, except one's just extended all the way through the center versus just going to the center, they are going to automatically create a right angle. So if I have a bisected chord, I know this angle is right, and the converse of that statement is true too. If I know that this thing is a right angle, then I know this has to be congruent to that. And so that creates just one more kind of unique situation that I can use this rule for. And it's this, okay? So I might tell you, okay, I've got a diameter. There is some chord out here that is either at right angles, I could tell you that, or I could tell you that, are bisected, in which case you can say, oh, if it's right angles, well, it must be bisected, or if I tell you it's bisected, you can say, oh, well, it must be at a right angle. But if I tell you the distance from here to here is 7, and the distance from the intersection to the edge is 2, can you figure out how long those are? Now, I don't have to draw the right triangles in, but I'm going to. I'm going to do this and this. Now, notice what matches up. This unknown value here, that x matches to that 2, and this x matches to this 7. Okay, so 2 over x, and, x over 2, from this triangle to this triangle. I almost got it wrong. Going from here to there, which means I've got to go from 7 to x. So let's do that one more time. My x to my 2, going from this big triangle to a small triangle, is the same as my 7 to x, because we know that this side corresponds to this side. All right? So you're like, oh, wait a second, I got 2 x's in here. I'm in big trouble. No, you're not. Because when you cross multiply, here's what happens. You get x squared, you get 14, and then you're like, oh, I know how to undo a square. I just take the square root. You're not dividing by 2 here. These are definitely not 7. They don't look like 7. This is kind of to scale. Not exactly. I drew up my hand, but it's close. So when I take the square root of both sides, I get x is, this is going to be 3 point something, a little bit smaller than 4. I'm going to guess 3.8. I'm totally guessing. But that seems about right to me. If this is 2, and this is 7, and this is more or less to scale, a value of 3.8 and a value of 3.8 seem about right to me. Okay, that's great. Ciao.